All right, so we're gonna do a couple little funky ones here. N, O, and F. Okay, even though the O is in the center, you're still gonna follow your rules for finding the central atom. Nitrogen has the most gaps, so I'm gonna put him in the center with the oxygen on one side, fluorine on the other. I know fluorine has 7 valence electrons, so 3 unbonded pairs with a bonded one is gonna give me 8 in the octet. I know nitrogen wants to have 3, so since there's only 2 guys there, I'm going to give him a double bond. Okay. And now he has 1, 2, 3. He needs 5 valence electrons. Oxygen needs 6. 1, 2, 3, 4, 5, 6. Okay. So again, when I'm checking 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, they all meet the octet. And the valence, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So even though you're now going to go a little bit of a faster way, or you could count electrons too. Nitrogen 5, oxygen 6, fluorine 7, so I'm going to have a total of 18 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, and 18. Those methods are acceptable, but we did not do them at the beginning because then people forget about octet and valence, and you would have put 6 electrons on this oxygen and the double bond, and your whole structure would have been wrong. So while you can skip the process now and you can use things like adding electrons to guide you, do not forget that when we're not in an ion, typically we're going to still meet octet and valence, so that is your goal. Sulfur dioxide, or sulfur trioxide, okay? Sulfur is going to be in the center, okay? Least electronegative, plus symmetry, plus, oh, and the same number of gaps as the oxygen. So that's what we did with at least electronegativity and symmetry for our answer. Okay. So, what do we have to do here? We're going to have some weird things happening, just so you know. Sulfur has weird things happening. I'm going to try to keep it year 1 level. When we're doing this, we're going to start off with filling in as much as we need to so that we got octets here. Okay. Now, when I do this, 8, 16, 24. But sulfur 2, 4, 6. Okay. So if you'd use this structure, you would then have to say sulfur is not meeting octet. But you have oxygens at a -1, -1, -1, and sulfur as a +3. So you can totally do it this way. Treat it like an ion. 6 times 1 sulfur plus 3 oxygens give me 18 total electrons. 2, 4, 6, 8, 10, I can't count, 24. Okay, 8, 16, 24. And it's just not an ion because you have 3 negatives and 3 positives. Now, because of formal charge, we know this is not correct, but for year 1, this is 100% an acceptable structure. So I'm going to move on. Oh, but what do I need to do? Non-polar, because no lone pairs, no different outer electrons, okay? And that works for your rules. And trigonal, planar, 120 degrees. And that guy up here, polar, different outer atoms, okay, but no fun bonds. So remember, fun bonds is hydrogen bonding with HF, HO, and HN. Those are the only things that give you hydrogen bonds. We do not have that here, so it is just dipole-dipole. So there's still unequal sharing of electrons to make it polar. There's just not hydrogen bonding because we don't have any intramolecular forces. These are the intras because they're the covalent bonds. hydrogen bonding is just a misnomer. It really should be hydrogen forces, but somewhere a long time ago somebody called it bonding, okay? Because it needs hydrogen in the intra. All right, and that guy was 2,1 bent 117. All right, I think I'm all caught up now. Okay, SO3, no brackets, no charge on the outside because they all balanced out. And again, make sure you note that your structure is this way because sulfur is not meeting octet. Oxygen, we're gonna have 3 times 6 or 18 electrons. Don't really have a central atom. Any one of those oxygens can go in the center. Okay. 2, 3, 4, 5, 6. If I try to make out with my octets, let's count and see what happens. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I know that's not what happens. I know I need to up my level of bonds. Okay. So if I give one oxygen a double bond and one oxygen a single bond, how many electrons do I have? 2, 4. Sorry, let me slide that up. 2, 4, 6, 8, 10, 12, 14, 16. And that means instead of a 2 lone pair at the top, I have 1, 2, 1. Still a bent structure, 117 degrees since it's a 1 lone pair structure. Okay, so we still get the correct number of electrons. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Everybody's still happy with valence and octet because he's not an ion. So if you cannot, with counting, get it to work this way, can level up that way. You could have also done it with the process method and gotten the same answer. If your double bond's on the left or the right, that is okay. Again, in year 2 chemistry, you'll learn more about what this actual bond structure is.